Okay, so today we're going to practice again on lesson point 1 and look at some problems together, and then you'll do the remainder of the ones for your classwork and homework. In the first section, it says simplify. When I look at number 1, 2, 3, and 4, these are all in exponential form. It's a base raised to an exponent. I'm going to convert these into an equivalent radical form. I'm going to start with number 2, and what I'm going to do again is I'm going to take that exponent, negative 5/3, 3 is the root, 8 is the base, and I'm going to raise it to the negative 5th power. This is a perfect cube, and this becomes 2 to the negative 5th power, which is 1 over 32, because remember, you move it down. 4 to the 1 and 5/10 power, number 3, becomes 4. Remember, 1 and 5/10 looks like this, which is 1 and 1/2, which is equivalent to 3/2 as a improper fraction. This now I'm turning into radical form. This becomes the square root of 4 cubed. Square root of 4 is 2, and 2 cubed equals 8. So for your assignment in this section, I want you to do 1 and 4. Okay, let's move this up. Let's see if we're recording. Okay, let's move this up and look at the next section. Write in exponential form. All answers should have positive exponents. I'm going to do number 7 in this section. So right now it's in radical form. I'm going to convert this to exponential form. All right, so if I look at the 5th root of 32, that is a perfect 5th root. That is 2, so I'm done with that. I now go to my variables. I have x to the 4/5 power, y to the negative 10 over 5 power. Okay, 2 can stay, x to the 4/5 can stay, but this needs to move to the bottom. So I get 2x to the 4/5 power over y to the positive 10 over 5. And 10 over 5 can be simplified to 2, so that's y squared in the denominator and 2x to the 4/5 in the numerator. Okay, let's go to the next section. Write in simplest radical form. You will need to put each radical into exponential form first. Okay, so number 8 should be pretty easy. You have the same base or same radicand, and you have the same root, so you can just multiply those together and keep it root 3. But let's go on to number 9. I want to do number 9 with you and number 11. So if I look here, I have the cube root of 9 times the square root of 3. Those are not the same radicands inside the radical, nor are they the same root. So we cannot multiply those together. I'm going to convert each one into exponential form, but if I look here, I can make 9 have a base of 3 by doing 3 squared. So under this radical now, I'm going to have the cube root of 3 squared times the square root of 3. I'm going to turn the cube root of 3 squared into exponents, which is 3 to the 2/3, and then I'm going to convert the square root of 3 into 3 to the 1/2. Now that I have the same base, I keep the base and add the exponents, 2/3 plus 1/2. These are not the same denominators, so I'm going to have to get the same denominators. Well, how do I do that? I will need to multiply 2/3 by 2 over 2 and 1/2 by 3 over 3. This is going to give me 3 to the 4/6 plus 3/6 power. And 3 to the 4/6 plus 3/6 becomes 3 to the 7/6. So this gets a little different here because I have an improper fraction for my exponent. So I have to rewrite that as 3 to the 6/6 because 6/6 is 1 whole times 3 to the 1/6, right? 6 plus 1 is 7. When I do that, 3 to the 6 becomes 3 to the first power, or just 3, times 3 to the 1/6 power. Well, what do I end up with? 3, and I'm going to now convert this to a radical, times the 6th root of 3. And that's my answer. Okay, let's make sure this is still recording. It's looking kind of funny, different today. Okay, let's go ahead and do number 11. Number 11 is the square root of 1/3 times the cube root of 9. Okay, so we have some things we have to remember. We need to get this into a base that is not a fraction, this 1/3. Oops. So let me remind you over here that 1/3 is equivalent to 3 to the negative 1 power. If I move this up, that's 3 to the negative 1 power. So now this becomes the square root of 3 to the negative 1 times the cube root, and let's change 9 to 3 squared. Now I'm going to go ahead and I'm going to write these as an exponential form. So this becomes 3 to the negative 1/2, because that's a square root, times 3 to the 2/3. Same base, I add my exponent. So I get 3 to the negative 1/2 plus 2/3, because I'm adding my exponents. Again, I have to have a common denominator. The negative 1/2 is multiplied by 3 over 3. The negative 2/3 is multiplied by 2 over 2. And that becomes 3 to the negative 3/6 plus 4/6. Now we have common denominators, and we can add that together, and we get 3 to the 1/6, which is equivalent as a radical to the 6th root of 3. Okay, let's see how our time is here. Looks like I've only used 7 minutes. Okay, in numbers, the bottom section in solving, I'm going to do 13 and 14 with you. Again, in number 13, we're solving, so we want x by itself. Before I can get x by itself, first I take care of the 6 by dividing, and I get x to the 2/3 equals 9. Now I get rid of the exponent by multiplying by the reciprocal. The reciprocal of 2/3 is 3/2. This becomes 6 over 6, or 1. So x equals 9 to the 3/2. I'm going to convert that exponent into a radical by doing the square root of 9 cubed. The square root of 9 is a perfect square. That's 3, and 3 cubed means 3 times 3 times 3, which is 27. In number 14, I want to get t by itself. To do that, I'm going to get rid of the 3 first. When I get rid of the 3, I get t minus 4 to the 2/5 power equals 4. That's gone. To get t, I've got to get rid of that exponent next by multiplying by the reciprocal, 5/2. So this becomes 4 to the 5/2. So I get t minus 4 equals 4 to the 5/2. Now I've got to do 4 to the 5/2 before I add this 4 with the t to the other side. So I get t minus 4 equals the square root of 4 to the 5th power. Square root of 4 is 2. Now I have t minus 4 equals 2 to the 5th power. 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 32. I'm going to add 4, and I get t equals 36. Okay, so for your assignment today, you will do problem number 1 and 4, 5 and 6, 8, 10, and 12. And sorry, there's not a lot of room here, and 15. So that's 1, 2, 3, 4, 5, 6, 7, 8 problems. As always, I like for you to reach out to me if there's anything I can help you with in doing this. Watch your deadlines for turning in the assignment, which I will post on the assignment page.